All right, guys. So let's go ahead and mute the microphones if you don't have your microphones all muted. So let's go ahead and don't worry. This is not going to last that long, guys. So here are today's notes. We're going to be talking about completing the square. So why, so this is supposed to be you guys, right? Just like the notes from this summer. So why must I learn completing the square? And it's going to help me in real life. Well, yeah, guys. I mean, you guys are all taking the SAT, ACT, and it definitely comes out there. It definitely will help you in physics when you're doing particle motion, and there's some particle that is falling, and that expression that is used to detail how it's falling is a quadratic. It's an alternate form of the quadratic formula, so it's used to simplify quadratics. Of course, you can use the quadratic equation as well. You're able to find the max and mins because you can always make a quadratic expression and turn it into a vertex form, which is really the same thing as completing the square. And we'll probably talk about that tomorrow, maybe. And we already talked about how it helps in physics. There's a very cool visualization on completing the square. Maybe Google it and see if you guys can find it. If not, maybe we'll do that activity sometime in the future. Hey, welcome, Viacana. I saw that you're in now, I hope. It does not help you for doing taxes. Uh, so sorry, I've been doing taxes for a long time and never have I used completing the square to do my taxes. So maybe call Delmer or a tax professional for that. It will not help you in driving. So you got to just take driving lessons for that. And it's useful for the SAT and ACT. Now here, guys, I'm just, making jokes. Maybe my jokes aren't that funny, so I apologize if if they annoy you. I try to make this not as extreme or not too cumbersome for you guys. So hopefully it's a little entertaining. But if it's not, well, I'm not that funny, so I apologize. All right, so let's chat a little bit about completing the square. So we already know that we can use it for quadratic expressions, ax squared plus bx plus c equals 0. This is what you usually call standard form. Hold on, it thinks, okay. Sorry, guys, it's because something popped up that said to admit. So I don't know if someone is out there that can't get in. Anyways, yes, you can use the quadratic formula. The quadratic formula to solve for x is negative b plus minus square root of b squared minus 4ac all over 2a. But sometimes that's cumbersome. And I mean, I don't know. I actually like the quadratic formula a lot. But completing the square is not too shabby, guys. So let's say that a equals 1 because that's always the easiest situation. If I have something like x squared plus bx plus c equals 0, the way to solve this expression, if you do not want to use the quadratic equation, is to move the c to the other side. And then you have x squared plus bx plus something equals negative c. And you don't have to write this down, guys. Just listen. Just take as much of this information in. So don't write any of this down. So hopefully you remember that Ms. Torres probably told you that what goes in there, well, it's b divided by 2, and whatever that expression is squared. So b over 2, close that squared. And whatever you do to the one side, you do to the other side. B over 2, close that squared. Now, why is this powerful? It's powerful because this trinomial just means 3 terms, will turn into a binomial, x plus b over 2 with a square on the side. And that's why it's so powerful, guys, because now, if I want to solve for x, all you got to do is square root this expression and then move this term to the right once you square root the squared. So that's why it's so powerful. And in case you're wondering, like, okay, Chavez, I understood nothing of what you just said. All you got to understand at the very minimum is that if I FOIL this expression, you get back to x squared plus bx plus b squared over 4 or b over 2. So just listen here real quick. If I FOIL this expression, look what you have. X times x is x squared, and then x times b over 2 is b over 2 with an x on it, and then b over 2 times x is another b over 2 with an x on it, and then b over 2 times b over 2 is b squared over 4. So here you have x squared, and then half of b plus half of b is a whole b. So bx plus b over 2 with a square on it. And sure enough, that is the same as that. And then when you want to isolate the x, you just move the b over 2 to the other side. So hopefully that made sense. If it doesn't, relax. We're going to do a whole bunch of problems. That was just trying to get the theory behind it. Okay. Here we go. I'm going to go slow, guys. I'm going to go real slow. What should I do first? How should I do it first? Okay, let's just go right into it. So x squared minus 2x minus 5 equals 0. I'm trying to solve for x. It wants me to use completing the square. All right, so what I'm going to do is I'm going to move the 5 to the other side. So x squared minus 2x, I'm going to have some magic number there, equals 5, because I moved it to the other side. So the magic number that goes there is b divided by 2, and whatever that is squared. 2 divided by 2 is 1, and 1 squared is 1. So there's my magic number. Whatever you do to one side, you do to the other. Now, why is this special? Just like I said a little while ago, it's special because this trinomial will reduce to x minus 1 with a square on the outside. Always. If you FOIL this out, you get x squared minus 2x plus 1 equals, and then 5 plus 1 is just 6. See? Simple. So now, to get rid of the square, guys, all you got to do is square root. Square root, square root. X minus 1 equals plus minus square root of 6. Square root of 6 is some decimal that goes on forever. I'll move the 1 to the other side. So you get x equals 1 plus minus square root of 6. If you wanted to say x subscript 1 and x subscript 2, meaning there's two solutions. One will be 1 plus square root of 6, and the other one will be 1 minus square root of 6. This is perfectly fine. You can leave it as 1 plus minus square root of 6. And there it is. See? And we did not use the quadratic equation. All right, here's another one. So we have x squared minus 14x plus 43 equals 0. And don't worry, guys. I'm going to see if I can go a little slower on this one. I'm going to move the 43 to the right. And you're going to have x squared minus 14x plus something in a little bit. That's going to be your magic number. Negative 43 because I moved it to the right. So here we go. I take the b, which is negative 14. I divide it by 2, which is 7, and then I square it. What is 7 squared? 49. Whatever you do to one side, you got to do to the other. So there it is, 49 and 49. So now this trinomial is going to reduce to x minus 7 with a square on the outside. The difference between 43 and 49 is 6. The 49 is bigger, so it's a positive 6. And now I'm ready, guys. See how easy it is? Now it's easy to get x by itself. I square root, and you're going to have x minus 7 equals plus minus square root of 6. Move the 7 to the other side, and you get x equals 7 plus minus square root of 6. Now, someone in group A, was it group A? It could have been group B. So just take note of this, guys. Someone in group A asks why I don't write this down, just listen. Why I don't have a plus minus in front of the x plus 7, just like I did on the square root of 6. And the reason for that, we don't have a plus minus on the x minus 7, because you first are squaring the x minus 7. So what does that mean? Think about it, guys. Anytime you have a number, any number, and you square it, it is never negative. So that's why I don't have a plus minus in the front. Because anytime I have a number, any number, it can be a negative number. When I square it, it turns to positive. Negative times the negative is a positive. So that's why I don't have the plus minus expression in front of the x minus 7. In case any of you are wondering, like group A was. Or it might have been group B. I have short-term memory here. So, all right. It's possible for your answer to be an imaginary number, guys. And you're going to see this one is an imaginary number one. So I'm going to move the 42 to the right. So when I do that, you get x squared plus 12x plus something in a little bit equals a negative 42. So now 12 divided by 2 is 6, and 6 squared is 36. So I'm going to write plus 36 plus 36. So this trinomial reduces to x plus 6, close it squared, equals, the difference between 42 and 36 is 6. The negative is larger, so I'm going to put negative 6. So you can already see here, just like I said, anytime you square something, it's never negative, so this has to be imaginary. Square root, x plus 6 equals, plus minus, put the I in the front there, square root of 6. Move the 6 to the other side, x equals negative 6 plus minus I square root of 6. It is by coincidence that all over the place, 6s came out. I am a man of the man upstairs, Jesus Christ. So no, there is no, it's just by coincidence that the number 6s came up over and over again. So there's nothing there, guys. So let's keep on moving. And yeah, hallelujah.
Mr.
So here we
Cruz,
go.
I have a quick question.
Oh, yeah. What's up?
I came a little late, so if you could post the link for attendance. I don't know if you already did that.
I'll post it up again. It's because
Okay.
it requires me to do like stop share. Well, it requires me to do several
Oh no,
things.
you're fine. Okay, thank you.
All right, no problem. All right, so here we go, guys. So this one here, notice that I don't have a 1 in front of the x squared. So I see 4, I see 16, I see 12, and I'm like, hey, wait a minute. All three of those terms I can factor out a 4. So factor out that 4 there. So I have x squared plus 4x plus 3 equals 0. And then you can just divide by 4, and those 4's cancel out. And you have x squared plus 4x plus 3 equals 0. Now I'm going to hold on. I'm going to slow down real quick. I'm going to write this in blue. Yes, I recognize that you can factor this out and get your answers really quick. In this case, when it's one of these, I would not use complete the square because factoring it out would get me the answer right real quick, real fast. Look, two numbers that multiply to give you 3, that up to 4. X plus 3, x plus 1. 3 times 1 is 3, 3 plus 1 is 4, all that equals 0. The only way this expression is going to be 0 is if x equals -1 or if x equals -3. So you're right, 100%. I would not use complete the square for this one, but because I typed this into the complete the square notes, let's go ahead and complete the square. So I'm going to move the 3 to the other side. X squared plus 4x plus something here in a little bit equals -3. So let's see what goes right here for that third term. 4 divided by 2 is 2, and 2 squared is 4. So 4, whatever you do to one side, you do to the other for balance. So now this trinomial is nothing more than x plus 2 with a square on the outside equals 1. I'm going to go square root, x plus 2 equals plus minus 1. Move the 2, -2 plus minus 1. And there it is, guys. Those are my two solutions. x1, -2 plus 1 is -2 plus 1 is -1. So x1 is just -1. And then here's x2. I'm going to do it in one line here. -2 minus 1 is -3. So -1, -3, just like here. Yes, I would not do complete the square for this one. I would probably just factor it out and then just equal it to 0. Fastest route. All right, I think we get the hang of it, guys, but let's do a few more just to make sure that we really got it. So let's go. X squared plus 16x plus 82 equals 0. Move the 82. X squared plus 16x plus some blank equals a -82. 16 divided by 2 is 8. 8 squared is 64. Okay, I can see something. Someone chatted something, so let me read. Oh, okay, thank you, Miss Orihuela, for posting that link for Viacana. Everyone's nice here. And now these three terms is going to be x plus 8. Put the square on the outside, and then the difference between 82 and 64, let's see, 64. 74, 84, that's 18. The 82 is larger, so -18. Square root, x plus 8 equals plus minus, let's see, 18 is the same thing as 9 times 2, and the square root of 9 is 3, and it's imaginary, 3i square root of 2. Move the 8, x equals -8 plus minus 3i square root of 2. I don't see any mistakes. I think we're good, guys.
I have a question.
What's up?
Could we leave it as the plus or minus I square root of 18, or we have to make it smaller?
No, I think Delta Math would accept square root of 18. But if you're like taking an engineering exam, or if you're trying to get into a really good university, they're probably going to want you to have it in reduced form. But square root of 18, if this were to be an AP exam, square root of 18 would have been perfect. You could leave it like that. You don't have to reduce it. All right, here we go, guys. Let's go to the next one. And yes, I see 5, 10, 130. So let's see if we can do this without a calculator. I'm going to divide everything by -5. And notice we haven't used the calculator yet, guys, so I think we're pretty good. We're pretty good. So let's see, x squared plus 5 goes into 10 twice, 2x. Ooh, do I need a calculator for this one? Here's how I do it. 5 times 10 is 50, so that means 5 times 20 is 100. And then I still have that 30, right? So 5 times 6 is 30. So let's see, 20 plus 6, that's 26. So plus 26. See, we don't need no dumb calculator. Sorry, guys. PG-13 here. So here we go. So now that we have that, move the 26 to the right. So x squared plus 2x plus some magic number there, negative 26. Divide the coefficient in front of the x by 2. So 2 divided by 2 is 1. And then square that guy. 1 squared is 1, so plus 1. Whatever you do to one side, do to the other to balance it out. So now this trinomial is going to reduce to x plus 1 with a square on it equals a negative 25. See? And then you just go square root. And you're going to have x plus 1 equals plus minus 5i. Move the 1 to the other side. X equals negative 1 plus minus 5i. Done. Okay. By now, you're probably like, okay, Chavez, you've done enough problems about completing the square. I kind of get it. I know what you're doing. I don't know exactly why, but I know that it's working. And if you know that much, for now, we'll accept it. Tomorrow, we're going to tell you why it works. So hopefully you'll be excited about that. Or who knows, maybe you're like, okay, darn it, I don't want to know, but I guess. But I hope that you're kind of liking this, guys. I'm going to leave this one for you guys to practice. Here's how it's going to look on the SAT. They don't tell you directly to use complete the square. You could actually use any method you want. So this actually, I probably should label where I took these questions from, because I think that's the right thing to do. This I stole from an SAT book. I it's a big blue SAT book, and I literally just opened it to the math section. And the first question I saw that required completing the square, I put in there. So I saw this one, and you could actually do this one with Quadratic Formula or complete the square. They're both, it takes about the same process for both, so it doesn't really matter. So here we go. What are the solutions of x for x squared minus 3 equals x? So you got to recognize it. Oh, it's a quadratic. You don't have a calculator on this, so you can't just type this into y1 and then into y2. That would be a good idea if you had a calculator, but in this question you don't. So move the x to the left, move the 3 to the right. So I'll have x squared minus x equals a positive 3. And it's okay to have a fraction here. So the number on the front there is a 1. So let's see. 1 divided by 2 is a half, and a half squared is a fourth. So I'm going to have x squared minus x plus 1/4 equals whatever you do to one side, you do to the other. And it's okay to have that 1/4 there. I'm going to turn this into just one fraction here. 3 is equivalent to 12 divided by 4. 4 goes into 12 3 times. And then when you do 12 plus 1, it's 13. So here's what I have. This trinomial is going to reduce to a binomial. It's going to reduce to this. X minus a half. Close it, put a square on it, equals 13 over 4. And now we just do what we've been doing all this time. Square root, square root. So we're going to have x minus a half equals plus minus square root of 13 over 2. In case you're wondering where that came from, guys, laws of exponents, this is the square root of 13 divided by the square root of 4. And the square root of 4 is 2, so that's why I put a 2 down there. All right, now all you got to do is move the half. So here we go. X equals, move the half to the other side, it turns to a positive. 1/2 plus minus square root of 13 over 2. The denominators are the same, so x equals 1 plus minus square root of 13 all over 2. And there it is, guys. I don't know, maybe you did it with the quadratic equation and you're like, no, quadratic equation is simpler. It does not matter. Actually, looking at it, I think maybe the quadratic equation would be easier. But it's the same thing, guys. You'll get the same answer regardless. All right, last one. This one I labeled medium easy. The only thing you got to know is the equation of a circle. Let's read the question here. It says the graph of the equation x squared plus 8x plus y squared minus 6y equals 24 in the xy plane is a circle. Okay, it's a circle, underlined circle. What is the radius of the circle? You know what? Let's add to it, guys, because they can always ask you what's the radius and then what's the center. What's the center of the circle? So let's add two questions there, because they can always ask you both of them. All right, so this requires some geometry knowledge. You probably did not, well, maybe you did, I don't know. Maybe in geometry you covered circles and the equation and standard form of a circle. So let me write it here. And there's actually two definitions of standards, but I'm going to write the more common one. Is x minus h close it squared plus y minus k close it squared equals r squared, where h comma k is the center. That's all you have to know to get this question right. So now that you know that, we have to make this expression look like x minus h squared plus y minus k squared equals r squared. So how do we do that? Well, let's see. Let's write it out. X squared plus 8x plus some blank here plus y squared minus 6y plus some blank here equals 24. Obviously, we're going to do it with completing the square because the notes are completing the square, right? But you have to recognize that while you're taking the SAT to do this step. So I want the x to be a binomial, or I want to have a binomial x minus something with a square. I want to have a binomial y minus something with a square, and well, completing the square will get us that. So 8 divided by 2, let me change my color to blue. 8 divided by 2 is 4, and 4 squared is 16. So I put a 16 here. Whatever you do to 1, you do to the other side. 6 divided by 2 is 3, or I guess negative 3 because it's a negative 6 here. So negative 6 divided by 2 is negative 3, but when I square that, you get a 9. So I put plus 9. And you always keep this symbol when you write your binomial here. So that's my sign here. So this is going to be an x plus 4 with a square on it, plus, and this trinomial y squared minus 6y plus 9 is going to look now like y minus 3 with a square on it, equals, let's see, 24 plus 16, 24, 34, 40, 40 plus 9, 49. We're good? Now, this says R. R stands for radius, so I should have put that in here. Sorry, guys, bad notes. R is radius. So, if R squared is 49, that means R must be 7. And the reason I didn't put a plus minus, guys, is because the radius can't be negative. So just whenever it's in context like this, just write the positive one. And there it is. There's my radius. Now, I haven't answered the second question. The second question is, what's the center of the circle? The center of the circle is negative 4. Well, let's do it correctly in math terms. So you should probably write the word center and then put a colon and then write your coordinate. Negative 4 comma 3. So there it is. That's my center of this circle, and the radius is 7. So I hope you enjoyed that, and I hope you get those questions all correct. So let's all come back